Okay, good afternoon class. So today we're looking at question from the past papers. On Metro Central, the paper you guys wrote, paper 2. We're at question 6. So it says in 6.1, without using a calculator, simplify the following to a single trigonometric term. Okay. As you can see, that's going to be 360 minus theta, so it's all stations to Claremont. 360 minus takes you to quadrant 4. So tan is negative, so it's negative tan alpha times. So sine of 2 alpha can be written as 2 sine alpha cos alpha plus, now that's already a acute angle, 440 minus 360. 440 minus 360 gives us 80 degrees. So that's going to be sine 10 over cos 80. So tan can be written as sine over cos times 2 sine alpha cos alpha plus, keep the first and change the second. So that's going to be sine 10 over, now the co-function of cos 80 is sine 10. That's now 90 minus. Okay? So that of course gives you 1. This is naturally over 1, the cos's cancel. Leaves you with negative 2 sine squared alpha plus 1. Now 1 minus 2 sine squared alpha is cos squared alpha, cos 2 alpha. And that's your solution. Okay. 6.2. In 6.2 we are told, given that sine of 60 plus 2x plus sine of 60 minus 2x, calculate the value of m if sine of 60 plus 2x plus sine of 60 minus 2x is equal to m cos 2x. Did we do this question? No? Okay. So I'm going to do the expansion on the left hand side, so that's going to be sine alpha cos beta plus sine beta cos alpha plus sine alpha cos beta minus sine beta cos alpha is equal to m cos 2x. So what I'm going to do, okay, as you can see here, that sine 2x cos 60 minus sine x cos 60 cancels. So that gives us 2 sine 60 cos 2x equals m cos 2x. Now that's a special angle, so that's going to be, so that's 31 to root 3. So 60 lies there, so it's going to be root 3 over 2. Make it a habit of, when it's without the use of a calculator, with a special angle, draw in the angle, okay, the triangle. Okay, so this basically gives us a root of 3, cos 2x is equal to m cos 2x. So therefore, the root of 3 is equal to m, or m is the root of 3. Okay? Now with that, we are given now the second part of the question where it says, if cos of x equal to root of p, without using a calculator, determine the value of tan 60. Now if you look at this here, what does this remind us of? The sum we just dealt with. Not so? And that's simplified into tan of 60 into, that was root 3 cos 2x. Can you see that? Again, so it's a root 3 cos 2x. So this is what is in the bracket there. So what we have is tan of 60, again that special angle. So it's 31 to root 3. Tan of 60 is opposite of adjacent, so it's a root 3 over 1 times root 3 times. Now cos 2x are going to change. Okay? Because we know what cos of x is, cos of 2x I can write as 2 cos squared x minus 1. If you had gone with 1 minus 2 sine squared x, then I needed to construct the triangle and get the third side. Okay, which is also possible. So that's going to give us 3, root 3 times root 3 is 3 into 2 cos of x. What is cos of x equal to? Root of p, not so? So that is the root of p squared minus 1. Now what is the root of p squared? P. So it's going to be 2p minus 1, which is 6p minus 3. Okay. And this question came in last year, the June paper, the June exam that passed. For the learners that really wrote maths, or the evening, the ABET students, this question came in with. Okay. Question 7. In the diagram, the graph of f and g. In the diagram, the graph of f and g are drawn with f of x equals. Let's pull this up here. F of x equals a cos x and g of x equal to sine bx, and x is an element of 0 to 360. So we just write here. So you got f of x is equal to a cos x, and g of x is equal to sine bx. Okay. So the first question says, use your graphs to answer the following questions. Determine the value of a and b. So if you look at a, the normal cos graph does that at 1 and minus 1. That's not 360, of course. But what do you notice here? It's going to 3 to minus 3. So your a value is simply going to be 3. We're looking at your your sine x graph. Your basic sine x graph does that in 360 degrees, 1 and minus 1. But what do you notice here? That 0 to 360 is covered from 1 to minus 1. So there's no variation on b. So then b is 1. So my equation is f of x is equal to 3 cos x, and g of x is equal to sine x, or 1 sine 1x. Okay. Then the next question says, determine the value of p. So if you look at where p lies at the point of intersection of the two graphs. I have the x value. So what I can do is I can substitute the x value into either f or g, and you'll get the y value out. Okay, so for 7.2, if we're going to substitute a, which is 71.6, and p, either into f or g. So I'm going to go with g of 71.6 is equal to sine 71.6 degrees. Okay, so that is sine 71.6. That gives us 0.95. If I had gone with the other graph, which is the A graph, it would have been 3 cos 71.6, which also gives you 0.95. Can you see that? Yes? Okay. Okay, so that's going to give you 0.95 on your P. Let's take it. Alright, and then 7.3, give the coordinates of B. Now if you look at some transformation here, as you can see, that A, that gap there, is about the same as this gap from there. Okay. So, if I'm going to calculate this distance there, it's simply going to be 90 degrees minus 71.6, which gives us 18.4. So that gap is 18.4, as well as this gap here is going to be 18.4. This is the gap, that distance. So it's going to be 270 minus that 18.4 gives us 251.6. So the coordinates of B is 251.6 and some y value. If you substitute that value into either F or G, you will see that the distance will also give you 0.95, but in the negative direction. Okay? So B's coordinate is 251.6 and negative 0.95. As you can see, it's on the negative part of your y-axis there. Okay? Just taking this off here. So, let's check here. Oops, nice. Now the next question says, write down the range of negative 3 g of x plus 2. So what is currently the range of g of x? So g of x is the sine graph. So the current range of g of x is from -1 to 1. Okay. What effect would that negative 3 have on the graph? The graph is stretched by a factor of 3 and then inverted because of the negative. So the graph is going to do that then this. 2, 3 and -3. So what is the range currently then? At this point the range would be still from -3 to 3. Then plus 2. What effect would that plus 2 have on the graph? Shift the graph 2 units up. So it goes from -3 to negative 1 and from 3 to 5. So it's going to be 7.4. So y is greater or equal to -1 or less than equal to 5. Okay. Then the next question says, okay, then we are told that for which values of x in the interval 0 to 180. So I must only do from 0 to 180, from there to there. Okay? For which f prime x is greater than 0. So f prime x, so it's to do with the f graph. So I'm looking for that from there to there. Okay? So what is your derivative? Your derivative is a gradient, not so. But it says where the gradient is greater than 0. What does that mean to say? The gradient is positive. Not so. So, if I look at 0 to 180 currently, what do you notice about the gradient of this graph? The gradient is always negative. Can you see that? But, what effect does that 15 have on the graph? That f of x plus 15. The graph is going to shift 15 degrees to the left. Which means to say this part of the graph, whatever that moves over by, will be then the positive part of that graph. The positive gradient. How do we know that? That as x increases, the value of y increases. As x increases, as you can see, it's decreasing here. So that's a decreasing part, where the gradient is negative. So it's from, if I move that point then, 15 degrees over, then it will be, if I move 15 degrees in that direction from 180, it will be 165. So in other words, x must be greater than negative 165, but less than 180 degrees. Okay. And at 165, it is neither increasing nor decreasing. So the turning point now moves with it, not so. Whereas 180 degrees is inclusive, why? Because at 180 degrees it's still increasing. You see that? Remember, at the turning point, the graph is neither increasing nor decreasing. Okay. And the 7.5, let's look at, is there 7.6? Yes. 7.6. So in 7.6 we are told that calculate the length of CD. So as you can see here, it's going to be, to calculate the length of CD, it's going to be the f of x graph minus, the g of x graph. However, I need the equation of f of x and g of x, or I need the x value at that point or the y value. One of those 2 points, okay? So it says calculate the length of CD, correct to one decimal place, one decimal digit, given that CD is parallel to your y-axis, and the y-coordinate of C is 2p. So the y-coordinate of C, so you got x and 2p. Can you see that? So in other words, I need to calculate x. In order to calculate CD, which we know, it's going to be the f of x graph minus g of x graph. So if I got the x value at that point, I've done the job. Well, the job is, so to say, done. So we know that point C is lying on the f of x graph. So we know that f of x is equal to 3 cos x. So we say that your y value is 2p. So it's 2 times your p value, which is 0.95 is equal to 3 cos x. So I divide by 3 both sides. So cos of x is equal to 2 times 0.95 over 3. It's 19 over 30. 19 over 30. So x, my reference, x angle would be arc cos of 19 over 30 gives you 50.7. That's my reference angle. But in which quadrant is this in? In which quadrant is this in? 360 minus. It's placed in the fourth quadrant. Remember that cos is positive. All stations to Claremont in the first and fourth quadrant. Clearly it's not in the first quadrant, so it has to be in the fourth quadrant. As you can see, it's between 270 and 360. So your x value here that we're looking at is actually 360 minus 50.7, which is 360 minus 50.7 gives you 309.3. Okay. So therefore, CD is going to be. So we go with with this fact here. So therefore CD is going to simply be 3 cos 309.3 minus g of x, which is sine of 309.3. I'm going to use the answer button there. So it's going to be 3 cos 309.3 minus sine 309.3. Give it 2 comments, 7. Okay. So question 8. I told that in the diagram below. A semicircle with center A. A little bit smaller. A semicircle with center A and diameter FAE. Going through B and C lies in the same horizontal. CB is 9 meters. CAB is 110 degrees. AD is a vertical pole, the plane, and is 2 meters high. Okay. Question says calculate the length of BD for 6 marks. Okay. So of course that's going to stand 90 degrees and that's going to be equal in length. Okay. That is 2 meters high. So if I got this length here, I can go with that triangle there. Okay. So we're going to first say that to calculate that the length of BD, I need to work out first the length of AB. And I have enough information to calculate the length of AB. Okay? So we're going to say only, we know that those two angles are equal. Remember, this is now a 2D and 3D problems. We don't need the reasoning unless the question says state the reason. Okay? So we know that ACB is equal to ABC, which is equal to 180 minus 110, which is 70 divided by 2, which is 35. I've used two theorems there, the sum of angles in a triangle as well as angles opposite equal sides. Okay, if they ask you to state the reason. So I'm going to go with the sine rule here. So it's going to be AB over sine 35 is equal to 9 over sine 110. Normally I say which triangle I work, but because of space here, I just leave it out in this case. So AB is equal to 9 sine 35 over sine of 110 degrees. So that gives us an answer of 9 sine 35 over sine 110 degrees. That gives us 5,49. 5,49. Of course, that is also the same length. Now, to calculate BD, I can either use, I can work out that angle here and then go with either sine or cos, but I can just use Pythagoras, it's going to be much easier. So BD squared is equal to 5,49 squared plus 2 squared. That's your Pythagorean theorem with DAB equals 90. Again, we don't need to state that because we're not busy with Euclidean geometry. Neither are we told to give a reason. So we just go with it that we don't have to give the reason. So the answer is 5,85. 5,85. 5,85 meters. Is that correct? Are you following the memo? Let's check if it's correct. Before you just need to sign the portfolios, no? So that's 5,495. They want 4 decimal places. 5,846. 2. Okay. Then the question says 8.2. I want you to calculate the size of angle CDB. CDB is the angle here. Okay, so we got a triangle now, looking like this. This is the angle they want. Okay, but this is now 5,8462. Okay, this is 9. Only marks at 3. If you're going to look at this triangle here, you should see that this is actually 2 congruent triangles. Can you see that? So here the sides are equal, 90, and there's a side. So it's side angle side that comes into play here. Okay, so those 2 triangles are congruent here. Okay? Which makes that also 5,8460. Okay, so at this point I can use the cos rule in the reverse. Okay? So it's going to be 9 squared is equal to 5,8462 squared plus 5,8462 squared minus 2 times 5,8462 times the same thing. Let's make that squared cos of CDB. Okay, So cos of CDB is equal to 9 squared minus, those are two of them. So it's 2 times 5,8462 divided by negative 2 times 5,8462. Okay, so CDB is going to be arc cos. This answer will come from you. Okay, so that's going to be 9. I know some of you go straight into it, but I don't memorize it, so there must be a square and the square as well. So I always manipulate the formula from once I do the substitution. There's that answer squared over negative 2 times answer squared. Okay, it's going to give you negative 18 point, negative 0, negative 0,18, and the number of course carries on. Okay, so I'm going to drop the negative, and then since it's going to be an obtuse angle, so it's going to be reference CDB is equal to, so I go arc cos or shift cos, arc cos of that answer gives you 79,34. But remember that cos was negative. In which quadrant is cos negative? In the second and third quadrant. Now we can't have a triangle with an angle that is greater than 180. Okay, it has to be less than, so it's in the second quadrant. So therefore, CDB is going to be 180 minus that angle. So it's going to be 180 minus that angle, gives you 100,66. The angle is 100,66 degrees. Okay. I think that part is behind the calculator. Just going to remove that for a while. Alright. Sorry, the space doesn't allow us to do much there. That's why I had to go behind the calculator. Okay. Now we're looking at question 9. No, I didn't cut the question with it, but okay. I need to write the question 9, huh? So in question 9.1, the question says, determine the size of angle E1. So here's E1. Okay. They gave us nothing in terms of the introduction to the sum, no? They just ask you straight, what is E1? Was there... I don't think I cut it properly here. It doesn't look right. Yeah, we are told that two circles intersect at C and E. For some reason I didn't focus. That's strange. Okay, it must be a short sight from my side. But okay, we are told that two circles intersect at C and E. G is a point on chord HF in the bigger circle. GE is a tangent to the smaller circle at E. So this is a tangent, so this angle here, no. GE is a tangent to the smaller circle. So that angle is equal to that angle. Alright. Then we are told that FHC is 75 degrees. D is a point on the smaller circle with the angle D being 73 degrees. Now it says determine angle E1. So people, we know that that is 73, tan chord theorem. Then we know that the opposite angles of a cyclic chord is supplementary, and that's how I'm going to calculate E1. Can you see that, people? So let's go. take it back. We firstly say that angle E2 is 73 degrees. Angle E2 is 73 degrees. Why? Tan chord theorem. Can't just say tan chord, no? You say tan chord theorem. Okay. Then we know that 73 degrees plus angle E1 plus 75 degrees equals 180. Why? The opposite angles of a cyclic chord, supplementary. So angle E1 is equal to 180 minus 73 minus 75. You will answer 32 degrees. Okay. Let's carry on. Oh, here's the sum. Yeah, I thought now, why wouldn't I cut that? Okay, but we not need this already, this question. Let's go to 9.2. In 9.2 we are told, make this a bit smaller here. In 9.2 we are told that C is a point on chord BE. If it's a point on chord E, if it's a point on chord DE with EF equals FD. A is the center of the circle that lies on FC. So if that's the center, we know that plane is equal to that plane, resulting in those angles being equal. Why? Angles opposite equal sides, radii. Then we are told that DAB is 86. So that's angle at center is twice angle at circumference. That's being 90 equal, that will be perpendicular. This bisector from center is perpendicular to chord. Okay. So all of that which they told us is already on the diagram, so I can move this down a bit. So in 9.1 it says, 9.2.1 sorry, we are told that determine the size of D2, angle D2. D2, which is this angle. So we know that D2 is equal to angle B2. Okay, why? Angles opposite equal sides, and it's your radius. Don't forget to write the radius. Okay. So that is not on the diagram. So then the D2, double D2 is equal to 180 minus 86. Then I divide by 2. So I will get angle B2 on its own. It's 180 minus 86 divided by 2. Gives you 47 degrees. So that angle is 47 as well as this angle. Make it a habit of writing that information on your script, on your answer sheet. Okay. Then the question says determine the size of DEB. DEB, and give you a reason for your answer. So DEB, so you go DEB. So it's this angle here. We spoke already about that angle. Angle at center is twice angle at circumference. Okay? So angle 9.2.2. The angle E is equal to half of 86, which is 43 degrees. Angle at center equals 2 times angle at circumference. Don't just say angle at center. You must say angle at center is twice angle at circumference. So this angle comes in to be 43 degrees. Okay. The next question, he says, prove that DACB is a cyclic one. So I'm going to take this off here. So the question is for DACB. So DACB. Now, for cyclic quads, okay, for cyclic quads, You must prove one of three. Exterior angle is equal to the interior opposite, or opposite angle supplementary, or the angles, the converse of angles in the same segment. Alright. So I already have this angle here, which is B2. So if I no, B1 is not going to work for us. If I can calculate C2, we've done the job, because I've got that opposite angle, which is 47. If I can prove that it adds up to 180, the job is done. Also we know that this is 90 degrees, no? Bisector from center is perpendicular to chord. So if I got that angle there, okay, then I can actually calculate C1. Why? The sum of triangles. Okay? And then if C1 is 47, then we prove that the exterior angle is equal to the interior. Can you see that, people? Okay, so let's just take all this off here. So that is a cyclic chord. So I'm going to calculate, firstly say that EFC is equal to 90 degrees. Why? Bisector from center is perpendicular to the chord, okay? 90. Now angle C1 is equal to 180 minus 90 minus 43 degrees. Sum of triangles. This triangle EFC. Okay? So that gives you 47 degrees. Is 90 minus 43 is 47. Okay? So that's now 47. So you see now that's your exterior angle. So we say since C1 is equal to D2, which is equal to 47 degrees. Since that is the case, therefore CBDA is a cyclic chord. Why? Because your exterior angle is equal to the interior opposite angle. Okay. So remember, when you're proving cyclic chords here, do not say that final reason cyclic chord unless you're saying conversely. Okay. The next question, question 10. There's a proof here. This proof was worth 6 marks, I think. Yeah. You'll find this, the link to this proof in the description box below. Okay, I'm going to do the proof in this video. So I've done all the proofs in one video. Okay, I'll send it in. I'll paste it in. This is the last one of the proofs that are required in Euclidean geometry that is needed for your exam. Okay, this is the last one. So just scroll through. We'll get it right at the end. Okay, because that's an hour-long video that I'm going to post that link to. Okay, with all the proofs there. 10.2. Question 9, let's look at your 10.2. What is 10.2? Alright, DC and DE. DC and DE are tangents to the circle at C and E respectively. So if that is the case, people, then the length of CD is equal to the length of DE or ED. Why? Because that's tangent from common point or external point, which will result in that being equal to that. Also, with that being tangents, C3 is equal to angle B. Okay? Yeah, C3 is equal to angle B there. Alright. Then we are told that A is the center of the circle. So, this is the center. Angle at center is twice angle at circumference. Okay, I'm already using arcs here, so rather take it off. Angle at center is twice angle at circumference. Okay. Also, this is your radius, your radii, which will result in those angles being equal again. Can you see that? Then we are told that B lies on the circle and BAE is a straight line. The question says, prove that triangle ABC is similar to triangle DEC. So when we start by saying in triangle ABC and triangle DEC. Okay? So the triangles they're looking for is A, BC and DEC. DEC. Then we can already see that C2 is equal to B and C1 is C3 is equal to B and C1 is equal to E2. You see we already marked it out. Okay, so where do we start? Let's start somewhere. So we say let angle C3 equal X. Makes things a bit easier. If that is the case, then angle B is equal to C3, which is equal, why can I just say X? Why? Tan theorem. Tan theorem. Okay. Then we know that E2, well, firstly we know that CD is equal to DE. This is tangent from common point. I'm going to take a calculator away then. Wait, this one. Tangent from common point, which will result in E2 equal to X. Okay, why? Because angles opposite equal sides. Okay? Then we know that ABA is equal to CA. Why is BA equal to CA? Radius, the radii. Then C1 is also equal to X. Angles opposite equal sides. Which now will result in C1 equals E2. Is your second angle. Okay? Hence the reason why they give you 5 marks. Okay? And the third one, of course, A1, angle A1 has to be equal to angle D. Why? Because that's the third angle of a triangle. So there we got 3 angles that are equal. Therefore, in the order they gave it, triangle ABC is similar to triangle DEC. Why? Angle. Okay, just check the order. So A corresponds with D, yes. B corresponds with E, yes. And C corresponds with C, yes. Okay. We just went to the other 2 angles there, but you should get the full mark there anyway. What I'm going to do is I'm going to say here that the triangle ABC is similar to triangle DEC. Okay. Definitely we're going to use that information. Alright. Let's take this out here. Then the question says, hence show that that is the case. Okay, that AE, so you see here, so you got AE, now we don't have, but we have BC, we have DE, and we have CE, which is that thing. Can you see? So from this fact here, we can say that, now number 2, we can say that, you can use the space at the bottom. Okay. So from this information, we're going to say that AB from here, no? AB over DE is equal to BC over EC equals AC over DEC. Why? Because sides in proportion. Okay, or you can just write the triangle ABC is similar to triangle DEC. Okay, either one of the two there. If you investigate and see what do they have here, we don't have an AE, but you got the BC. We have a DE, and they have a DE and BEC. That one there. So clearly, it's those triangles, those ratios we need to work with. However, DE is over. Okay, we'll come now back to that. But AB is the issue. You see, there's no AB, but there's an AE. No wait. DE we have EC. So this one must come up, and that one must come down. No? So in other words, before we go into that, let's just get it in the right order. So BC is equal to DE over CE. But AB is not on its place according to the ratio. So you go to the diagram, AB. AB is the same as AE, not so, which is the same as AC. So this length is also the same. Why? Because that's your radius. Not so. So I say AE is equal to AB. Why? Because that's your radius there. So therefore, AE over BC is equal to DE over CE. Okay. So that's an add here. Number 2's question was AE over BC is equal to DE over CE. Okay. Otherwise, the rest is on the diagram. Was that the last question? With regards to the diagram. Yep. We went to question 10.3. I don't know why there's 2 dots there. That was a mistake. 10.3 in the diagram below. Let's make this a bit smaller. Okay, this is 10. This is the last question. Right, let's finish up. So here we are told that in the diagram E lies on AB, E lies on AB, and F lies on AC in that triangle ABC, with those lines being parallel. So if lines are parallel, you divide the sides in proportionally. Then we are told that angle that G lies on FB and H lies on FC. With those lines being parallel against the sides are in proportion. Then we are told that AE is to EB as 4:5. So you've got to get 4K and 5K. Then FG is to FB as 5:8. So it's 5A and 8A, so there's going to be 3A here. Alright. So that's that. The question says 10.3.1. They wanted to know what is AF, the numerical value of AF over AC. This is the whole length here. AF over AC. Now AF over AC is the same as AE over AB. Why? The proportionality theorem, with FE being parallel to BC. You just needed to write that, you don't really need to write proportionality theorem. So that is simply going to be 4k over 9k, which is 4 over 9. Okay? So that I used A, so this I'm going to say as 4b and 9b and 5b. Okay? You all agree with that? The next question says, calculate the value of HC. Take this off here. Here they want to calculate HC over AF, which is our length here. No, but AF is 4B. So HC, I need to calculate, not so in terms of B. Can you see that? So we know that HC over, I must go this whole length, because the whole length is known as 5B, is equal to HC over 5B is equal to that length, which is 3A, over the whole length, which is 8A. Again, the proportionality theorem, with GH being parallel to BC. So the A's cancel, of course, so HC is equal to 3 over 8 times 5B, which is 15B over 8. So that is 15B over 8. But they want to know HC over AF. Right, HC is going to be 15B over 8 divided by AF, which is 4B. Okay, so that's over 1. So that will give you 15B over 8 times 1 over 4B. The B's of course cancel, gives you 15 over 32. So 15 over 32. And then the last question was this one here. So here they're asking you with regards to the ratio of the areas. So they want to know, calculate the value of the area of the quadrilateral EBCF. So EBCF, that quad, over the triangle AEF. AEF, which is that triangle there. So what you do is to calculate this quadrilateral here. It's simply going to be, when you go straight in the calculation, it's going to be the big triangle minus the small triangle. Can you see that? So the big triangle is going to be a half 9k times 9b, which is the it here. I'm using the sine rule, so it's going to be sine of angle A, minus the small triangle here, which is a half 4k times 4b sine of angle A. If I subtract the big triangle from the small triangle, I'm left with that quad. And it's over the small triangle, which is a half times 4k times 4b sine of angle A. So what I do is in the numerator I take out the half kb sine A as a common factor. I'm then left with 9 times 9 minus 4 times 4 over half times 4k times 4b sine of angle A. So now that cancels, the k's cancel, the b's cancel, and the sine a's cancel. So in other words, I got 81 minus 16 over 16. And 81 minus 16 over 16 gives you 65 over 16. And that's the ratio they wanted to be. Okay? And that basically concludes these papers. People enjoy the rest of your day. Good afternoon. I just need you guys to sign quickly before you leave, okay?